Hello everybody and welcome to the Loadbalancer.org webinar. Today we will be discussing 4 routes to multi-site resilience. You are joined by myself, Oliver Warren, one of the sales engineers at Loadbalancer.org. Aaron West, one of our technical architects at Loadbalancer.org, and Jed Ward, one of our lead sales engineers at Loadbalancer.org. The agenda for today, after my brief introduction, is to discuss the following. We will be going over multi-site challenges. We will then go over 4 possible routes for maximizing uptime. We will then give an outline of routes 1 to 4, followed by a brief summary from Jed Ward, and then it will be followed by a Q&A to ask any questions you may have throughout. We will then discuss next steps and close the webinar. In regards to asking questions, Zoom webinar participants are muted by default. Please use the Q&A button on the Zoom menu bar to ask any questions. Feel free to ask questions throughout the webinar. However, all questions will be saved until the end of the presentation for a Q&A session at the end. So, are your services located in multiple locations? Let's look at some of the common issues. Are you experiencing troubles with scaling out over more than one office location, whether it be a data center or cloud? We will help you discover techniques to deliver high availability across multiple locations. You may be looking for simple solutions to common problems. We will talk about active backup configurations for high availability in any environment. Or you could be considering complex overlay networks, or worse, something like Anycast. Have you considered using global server load balancer for alternatives that don't require common subnets across locations, or the use of complex routing to achieve scalability? So, what are the 4 routes? The 4 routes we're going to be going over are Layer 2 multi-site, Layer 3 multi-site, global server load balancer or global SLB in multiple locations, and we're going to be going over disaster recovery failover groups. To discuss the first 2 scenarios, I will be handing over to Jed Ward.
Thank you, Ollie. So just a bit of scene setting really to start. Service expansion and use of IT has grown exponentially over the last few years. And because of that, there's a reliance on data, whether that's corporate data or services that we consume from home. The growth of use has meant that businesses that provide that data, whether it's to their own users or commercially, need to ensure that they can provide scalability and availability of those resources. The always-on culture we now expect means that we want access to everything immediately. In order to do that, people need to provide very high levels of resilience and high levels of performance. And the way that that's been achieved is by adding clusters of services, adding larger numbers of servers to actually cater for the volumes necessary. And in order to simplify that, the use of load balancing has become very prevalent. In essence, the load balancers become the target for all the user networks to actually connect to those services. And the load balancers themselves actually health check those services. So they will provide the user with a service that they know is alive and performant. In doing that, they ensure that the user experience is as good as it possibly can be. Now, typically those businesses, and a lot of businesses, start with a single data center for those services. They add the required number of servers to cater for the expansion and the resilience necessary. But in those environments, a single building is a single point of failure. If we look at the simple diagram here, we've got 2 load balancers, which provide a high level of resilience and a number of servers behind it that we're health checking to ensure that they're operational. But if I lose this data center or this building has an issue, and we've seen that recently with fires in hosted data centers, anything like floods and obviously the pandemic can have an effect on availability of any site anywhere. So how do we ensure, or how can we simply ensure that we can provide those services from multiple locations? The first thing, and where we're talking layer 2, is really just to stretch the services or locate the services in multiple buildings. In doing this, what you're looking at is the same services that were in one data center really just being located in 2 different centers. Now, this is commonly used as layer 2 connectivity in campus type environments, seen widely in healthcare, education, finance, government, and a lot of tech organizations that have large campuses with a large private network encompassing the whole campus. So fiber links between the buildings and moving services into the different locations gives you some level of resilience here. The load balancer, the active passive pair, actually still carries out all the health checks of all services in all locations. And in the event of a load balancer failure, the passive load balancer would take over and the users would not see any effect on those services, with each load balancer having access to all services in all locations. Now, this is fine. This provides a high level of resilience. It still has the same scalability that we can see and that we expect. This is a little like having initially a simple road. We add numbers of servers, and that gives us an element of adding lanes to a motorway. But there is a point where you can't add any more lanes, so we add the second motorway. We add another road alongside it. That gives us a level of resilience. If one road is closed for any reason, we still have the other road. In theory, smart motorways are like this, where you can access all lanes from as and when required, but a lane could be closed at any time. The services, if we lose one building, although users may have to relocate, the services are still available through the other building, even though maybe in a reduced way. So why do we need 2 buildings, or why do we need multiple sites? Another simple analogy is all passenger aircraft have to have 2 engines. Now, they can fly on 1 engine. They don't necessarily need 2 to take off or land. But I'm sure you'd be quite happy that if 1 engine failed, the plane can still fly and land safely on the other. So if we lost 1 building, the services are still active and they're still available to all the users. Now, commonly, the technologies used for this are maybe dark fiber in a private network, but they can also be stretched VLANs using a multitude of technologies with overlay networks, whether that be the SD-WAN type technologies, VXLAN or OTV, that can actually stretch layer 2 networks over dispersed data centers. And really, some of the benefits of this are you're not actually adding anything other than the second building. The services that you had in one data center are just being stretched across the 2. That makes it relatively low cost. You're normally utilizing a network that you already had in place between those locations. So it's a relatively cheap way and simple way of providing some level of resilience in a network. The most common uses, as I've said, are campus-based DCs, and it still just relies on a simple active passive single cluster of load balancers. The reliance of the links between the buildings is key for this, so that each load balancer has access to the other and can health check all the services necessary. And this is really the sort of simple campus scenarios. But what happens when we want to expand past that? Obviously, a lot of businesses are geographically dispersed, offices in multiple locations. And in that case, we move to a slightly more complex layer 3 interconnectivity, which is really the second scenario that we're looking at. So in layer 3, what we predominantly have is an actual active passive cluster in each of the sites. So this provides local resilience of services for the users that are geographically located near that site or on the site. All the services are available in both sites and can be expanded and scaled as necessary to provide the resilience required locally and for the performance required for the local users. Predominantly things like whether it's via a routing protocol or split horizon DNS will ensure that people will actually access their local site. And this basically provides the highest level of performance available for them, and each site individually can be scaled. In the event of failure here of service on one site, the load balancers themselves can actually fail over a service on a service by service basis. So they can understand that there is a fallback position, which is the second site. So although it's not actively health checking the second site, it knows that if its local service fails, that service would be available on the other site. So it directs traffic to that. And that's obviously still reliant very much on the layer 3 connectivity. And in this scenario, we're predominantly talking about large private networks still. We're not really talking about internet-based services and sort of internet-based connectivity. So it's still a large private WAN with access to multiple data centers. So what this gives is multiple HA clusters, resilience within a site, and a fallback position that can be used between sites should a single site service fail. Users, if they have to go to a secondary site, may see a performance degradation, but at least the service is still available. So this provides some level of geographic capability, and it can be DR, it can be just used for high availability services in private networks. It doesn't really give us full global load balancing. What it is doing really is providing service level scalability and service level resilience within a private network. So in order to move on from that, let's pass over to Aaron, who's going to discuss the last two scenarios.
Hi, everyone. Okay, so thanks, Jed. That was wonderful. Over to me to discuss what exactly is global server load balancing. So global server load balancing can be introduced either on its own or alongside other forms of load balancing, like local server load balancing. It offers far more flexibility when you're designing and deploying your scenarios than you get with traditional load balancing alone, giving you an extra layer in the DNS end. Traditional methods such as layer 4 and layer 7 load balancing will sit in line, seeing all traffic from the client to the server. This gives you a real-time view of the application and its availability, which can be extremely useful. However, sometimes this can also mean that the load balancer itself becomes a bottleneck, seeing all of that traffic. Methods such as layer 4 direct server return, which as a company we love, can also be used to address some of those scalability problems, but it only really helps scale up the egress traffic, as ingress would still flow via the load balancer. This helps make the case for using a GSLB in a direct-to-node approach, because some technologies, such as storage, where achieving the maximum throughput is definitely a must, GSLB is really a perfect fit. The other primary use case involves supporting multiple locations or sites. You may even need an extra layer of load balancing in front of your East Coast and West Coast DCs, favoring one over the other for DR purposes, or just load balancing between the two in an active-active arrangement. Standard distribution techniques are supported, such as round robin, failover groups, and also topologies. Now, topology is kind of the interesting one because topology mapping can be introduced on top of your normal round robin schedulers and to offer an extra layer of effectively location affinity, which allows users to be directed to specific client subnets or to a preferred location, shortening their trip to the application and reducing the need to use costly cross-site links. So, is all this just fancy DNS? We've talked about what GSLB is in theory and where it differs from typical load balancing. However, GSLB obviously works at the DNS layer, so what differs it from DNS itself? To answer that, the answer is kind of yes and no. Typically what makes a GSLB is the addition of location and health awareness, so knowledge about where the possible sites are and also their health to the actual endpoints themselves. This offers the ability to then make intelligent decisions based on this information. Round robin alone has been used for many years as a simple solution, but falls short as it will often serve up failed results to customers without having proper health checks in place. And it also lacks awareness of where clients are actually coming from or where we might want to send them, such as local provisions of servers or to closer geographical locations. Typically, it's just going to return in a standard DNS way, multiple addresses in a random order, which can then lead to a bad customer experience without the addition of those health checks and location awareness. So let's have a look at a diagram. This diagram is an example of two sites. We show a direct-to-node approach here for simplicity rather than having any extra load balancing in place, which makes it simple and a GSLB-only deployment. The client performs a DNS lookup to their local DNS server, and this is shown in Figure 1. Next, because we've delegated the subdomain that's actually used by our application, the DNS server knows to forward the request to the load balancer and retrieve an answer. This is shown as step 1 in the diagram still. Once the client receives that answer, it is then able to connect to the node returned, which is shown as step 2 in our diagram. The GSLB will run health checks on both sides, so it has full knowledge of the server availability and can direct users to an available online node. Let's move on to the next one here. So this diagram now shows a 3 sites, in fact 4 locations. Basically what we're showing here is that site expansion is fully supported. You can deploy this solution across several data centers or even cloud environments, returning up to a maximum of 1,024 results for pretty much endless scalability. The solution is hugely scalable and will grow alongside your network needs. And users from our head office can be accessing their local on-premise provision, while any of our external users can be sent to one of our up and healthy sites elsewhere. In this diagram, we show, as I say, 2 office locations with users and 2 popular cloud environments with external users coming from branch office locations. But all of this is one GSLB deployment. So you're being sent to the correct place based on where you are and the availability as mentioned. So we've mentioned delegating. So delegating or configuring what's known as conditional forwarding is pretty straightforward in all major DNS servers, making it fairly universally easy to configure. The GSLB only supports A or any records, so CNAMEs can be configured in your own DNS infrastructure and then pointed at the A record that we've actually delegated to the GSLB, giving us the flexibility of other record types and to do things like wildcards and things like that. Generally, the steps involved to actually do this is you configure your A record for each of your load balancers that you're deploying in your sites. Then you would configure a delegation or the conditional forwarding for that specific subdomain, pointing it to the load balancers A records that we configured earlier. And as I say, this would be supported in major DNS servers. So in the pictures in front of you, you see Microsoft's Active Directory DNS, and also an example from Bind. We also mentioned site affinity or topologies. So it's been mentioned a couple of times. What do I actually mean by that? Site affinity is provided by topology-based load balancing, which distributes the traffic matching you to your local resource based on the topology and therefore your location that you have configured within your GSLB. This offers location affinity, helping users stay within their local office or site and avoids the use of expensive or contended links when accessing resources. Using the topology-based algorithm, TWRR, the GSLB service can distribute the traffic while matching the source address to the requesting client's DNS server. This will then tie together sources and destinations, keeping users in their local site very simply by just matching source IP addresses to the actual locations available subnets. Topologies consist of a list of IP addresses and subnets grouped together. Topologies still offer failover should all resources be down, and failover is up to you. We can either specify to failover to any remaining real server, or we can even reject if it's not desired. You can assign a 0000/0 to a topology to create like a wildcard and a default site effectively for any external traffic. So if you do need to prefer a site for anything that doesn't match, you can use that as a trick to convince it to do so. Lastly, we've spoken an awful lot about site affinity and topologies and things like that, and how generally we're running in a round-robin type fashion. We do support another mode of operation, and that's known as failover groups. So failover groups solve your simple disaster recovery problems when you have a need to failover between active and passive sites or services. You can specify multiple failover members, and the GSLB will prefer the first healthy site or server in that list, only then failing over due to negative health check results. In this example, we also do local load balancing, unlike our previous diagram. So you'll actually see that we have a pair of HA load balancers in each of the sites and local VIPs. This is to offer effectively a belt and braces approach. So you have the DNS layer in front, handling the multi-site load balancing, and in each site you have local server load balancing being handled by the pair of load balancers. This method is great when you have a DR site, as you know, some of your sites might actually not be fully functional. So having a staged failover with the failover group means that you can have a primary active fully functional site and a number of other sites which may be partially functional or indeed may be turned down in a DR mode, ready to be turned up should a problem occur. I hope all that makes sense, but if you have any questions about that, we are finally getting closer to our Q&A stage, so you can certainly ask as many questions as you like at the end. But for now, back over to Jed for a summary of what we've discussed so far.
Thank you, Aaron. I mean, that was a fairly quick run through sort of 4 different scenarios, 4 different deployment methods, which are more around underlying network interconnectivity and interactions between the sites. We've looked at a few different failover scenarios and failure scenarios. All of these are really designed to provide resilience to services, resilience in the network. The key really is to understand the failures you want to protect against and to select an appropriate solution, or just to select a solution that allows you to improve service performance and availability. But understanding that means that you can select an underlying network topology and mix and match the methods that we've shown. So commonly, even if we have layer 2 connected data centers, we may still provide some level of global server load balancing as well. And in multi-site environments at layer 2, layer 3, cloud, or using GSLB, we still have the capability of local service level failovers using fallbacks. Hopefully that's just given you a brief overview. And the idea really is to defend the network as and when required. I think we're probably moving towards questions, so I'll pass back to Oliver.
Thank you very much, Jed and Aaron. So we will now be taking questions from the floor. It is not too late to ask more questions. If you wish to ask more, please use the Q&A option in Zoom. If we have time, we will take verbal questions. To ask a verbal question, please raise your hand. We have had some questions come in already, and we're going to start with, you mentioned GSLB health checks. What health checks are supported?
Hi, that's a great question. Yeah, so we handle simple TCP level health checks as the sort of basic. I mean, in our standard load balancing, we refer to those as connector ports. So is the port open at TCP level and does that work? We also have the ability to do a slightly higher level, what you consider a layer 7 check. So we can do a HTTP based check that will check, for example, did we get a 200 OK, or was there a specific string, for example, on the page? But my favorite part is actually our use of external health checks. And this is throughout our entire product. We do this at layer 4 load balancing, layer 7 load balancing, and in our GSLB, where you can basically write a script in your preferred language. I mean, we support shell script, we support Python, we support Perl. And using that, you can pretty much get it to do whatever you like. So in simple scenarios, you might want it to do something specific. You could, I don't know, send a test email in the case of an SMTP server. Or in more complicated scenarios, you might want to say, check that the actual application is ready and available, but also double check that the database is available and the storage location. So you could actually have a check that did 2 or 3 things before actually passing a service as healthy, which is why it's so powerful.
Thank you very much, Aaron. Another question has come in says the slides touched on 2 and 3 layers of load balancing. Papercut HA requires a layer 4 NLB, which was not articulated. So what does 4-layer NLB look like?
Yeah, I'll take that one, Olive. Thank you. So really, what we've been looking at is the underlying connectivity of sites, whether they be stretched VLANs at layer 2 or routed VLANs at layer 3, and then some of the GSLB that goes over the top of that. The actual load balancing algorithms that are used either at layer 4 or layer 7 within a site or between sites would use that transport path, but would be more of a configuration within the load balancer itself than the interconnectivity that's required between the sites. So if you're looking at something which needs a layer 4 connectivity between the sites, then you may just have a layer 4 network load balance solution. You may want to make sure that you have layer 2 connectivity between the sites depending on the deployment method. If you're using something like a direct server return, they need to be in the same network, the same logical and physical network. And in order to do that, you would configure the load balancing at layer 4 on the load balancer itself, and the underlying network at layer 2, or using an overlay network, possibly on a layer 3 link, would provide that physical connectivity. So there's a difference really between the interconnectivity of the data centers and the load balancing methods that we use that match that on a single site or across multi-sites.
Perfectly put, Jed. Thank you very much. A third question that's come in is, do you support my public DNS provider? Aaron, would you like to take that one?
Yeah, I mean, that should be absolutely fine. I mean, some DNS providers might have limitations in terms of what they can do. I mean, you should be able to handle a delegation, as that's pretty much just saying these name servers look after this subdomain. So that's pretty straightforward records to create, just NS records typically. Whether you have support for conditional forwarding, which you would have in some of the sort of, Microsoft DNS server or, whatever else, where you can actually say, under these circumstances, forward this domain. So it's a little bit more fine-grained control is another matter. But yeah, I mean, generally, it's not going to be too much of an issue to set up a delegation in any DNS server, as I touched upon in the slideshow.
Thank you very much, Aaron. And one more we have to throw out there. I don't mind who answers this one. Can you weight servers across a multi-DC deployment to prefer local servers over remote ones?
Weight servers, no. So the thing with weighting is that if you weight servers, let's say I set one server with a weight of 1 and one server weight of 100, the server with a weight of 1 is still going to get some traffic. It's going to get a different amount of traffic, but it's still going to get some. There's no way with weights to entirely skew it so that traffic goes locally and the other one's just there as a backup. That's more of a fallback server arrangement, or maybe failover groups if we're talking about the whole GSLB thing. However, we do have ways and means of dealing with this with GSLB, in that what you can do is use the topology-based load balancing, which again we touched upon in the slideshow, which will say match your client subnets to the virtual service or the provision of the service itself's IP address. So you can create a list of IP addresses and it will compare that list to what you've got. And then it will decide, okay, the clients who have talked to the DNS server in their local site have then talked to the GSLB, which has then said, okay, we can see you're in site A because that's where that subnet for that DNS server is. So we're going to serve you up the site A provision of the application. So we have the ability to do that. It's just done with a little bit more complication than just weights alone.
Thank you very much. You also touched on running Heartbeat across multiple locations. What is the minimum link speed in order to do this?
Hi, I'll grab that one as well. I mean, in theory, you can do that over a 10 megabit link. It's in terms of the actual speed, it's not too much of an issue. We would need to make sure that it's not massively contended, because latency can come into a bit of an issue, especially once you've got a lot of traffic running through it. I mean, I think typical deployments you'll be fine, but if, for example, you were to do a big backup over that link overnight, you could cause late heartbeats, and then that could lead to technical problems. So either you need to ring fence it and put some kind of priority on the VLAN that you're using for the heartbeat communication, or you need to dedicate a link. And in the case of a single data center, you have options to use a dedicated network cable or a serial connection as well. So there's lots of options of how to run Heartbeat.
Thank you very much, Aaron. That is it for the questions. At Loadbalancer.org, our mission is to ensure that its clients' businesses are never interrupted, ensuring zero downtime. If you wish to contact us, please use the contact details on screen and we'll be happy to talk to you. If you have any further questions that you think of once the webinar is finished, please do get in contact and we will be happy to discuss with you. That is the end of the webinar. Thank you all for attending. If you get in contact with us, we will be happy to go over anything to discuss today. We are offering complimentary one-on-one sessions with all webinar attendees. Thank you for attending our webinar on multi-site resiliency. Have a great day. Goodbye.